All right, y'all. So we're working with increasing and decreasing behavior today and Extrema. All right, so let's go ahead and jump in. Okay, so increasing, decreasing, and constant. Okay, so for any given function, okay, it's always going to be one of those three. It's either increasing, decreasing, or staying the same. Okay, and that's what we're referring to here. So let's go ahead and kind of talk about the informal definition, and I'll show you an example of what the formal definition is of increasing. But typically, it's just kind of an unnecessary mathematical definition for each of these three, if you ask me. All right, so let's go ahead and talk about what each of these are. So increasing, okay, so that means the function is going up, okay, as it goes left to right. Okay, so if you think about it, right, we read left to right. Okay, so you want to sort of read this function left to right when you're thinking about increasing, decreasing, and constant. Okay, I think the one thing people get confused about is they'll try to do it backwards. Okay, but you always want to look at the function from left to right when you're talking about increasing, decreasing, and constant functions. Okay, so the function is going up as you go from left to right. Okay, for decreasing, the function is going down as you go left to right. Okay, and then constant, the function stays the same as you go left to right. Okay, or another way you could think about it, right, is it's basically like horizontal. Wow. Horizontal. Okay, so that's what's happening when you have a constant function. All right, so if you notice, I put the highlighters here, right? We've got blue, pink, and then green. Okay, so I'm going to go ahead and just label each one of these parts of the function. Okay, and I'm actually going to go ahead and mark it real quick because there are some spots where it's changing, just so I know where to stop. Okay, all right, so increasing. Okay, the function is increasing here. We'll go ahead and be consistent. We've got it's increasing here, and that is it. Okay, it is either decreasing or staying the same everywhere else. Okay, so it is increasing on those parts, right? So if you remove your pencil, right, as we go left to right, the function is increasing. Okay, so as I go, again, left to right, so I'm going from the left to the right, and my function is getting bigger. Okay, decreasing. Okay, that's going to be this section right here, and then also this section right here, and then this section right here. Okay, and then obviously it continues, right? It's looking like it's going to continue to decrease based on those arrows. Okay, and then the constant part, that's this right here. Okay, so in that little section is where it's staying constant. Okay, so again, to kind of get you the formal mathematical definition, just to show you, I'll go ahead and write it. Okay, so what it is for all x1 and x2 within, okay, that symbol is within an interval, so a comma b, okay, within an interval, f of x1, okay, is less than f of x2 for all x1 and x2. Okay, for all x1 less than x2. Okay, so if you ask me, it's unnecessarily detailed, but essentially it's just saying for each point or for each x value that is less than another x value. So for example, here and here, right? This x value is less than this x value, right? This could be like, I don't know, -9, -8. Okay, it's saying that the y value at that bigger one right? The y value is also greater than the y value at that smaller x value. So again, it's very formal definition, but if you just want to know what increasing, decreasing, constant are, you can just look at these top ones. I'm not going to write the formal definition for decreasing and constant, but we can certainly kind of put it in this same format. Okay, so let's go ahead and kind of talk about how we refer to increasing, decreasing, and constant. So what we're actually going to say is we're gonna kind of ask ourselves in these next questions, like, what are the domains for increasing, decreasing, constant for these particular functions? So we're asking ourselves, at what x values is it increasing? At what x values is it decreasing? And what x values is it constant? That's the kind of thing we're working with coming up down here. Okay, and the first thing that we need to make sure we note is that you're always going to be dealing with open intervals. Okay, when you're talking about increasing, decreasing, and constant, you are always working at open intervals, and those intervals are always going to be domain. Okay, you're always going to be talking about at what intervals is it increasing for your x. So where, from this x value to this x value, is it increasing, decreasing, or is it constant? Okay, and so just as a reminder, right, those open intervals are always going to be with parentheses. Okay, so it could be a number here and a number here, and the reason is at an exact point, right? At a change. Okay, like if you look at this point right here, at an exact point, we don't actually know if that's increasing, decreasing, or constant at that exact x value. Like when it changes, we don't know what's actually going on right there. Okay, so we have to leave it as parentheses because if we were to put brackets, we would be implying that at this exact point, it's increasing, decreasing, or constant. Okay, and it is none of those because you have to have multiple points. You have to have a kind of a domain, right, or a section, and at an exact point of change, right, where this would be a change, right? This is a point of change. This is a point of change. I'll just tell you now. And so we don't know what's happening at those exact points where the increasing, decreasing, or constant is changing. Okay, so that's actually a pretty important concept, especially moving forward towards calculus. Okay, just something to keep in mind. Okay, so increasing. Let's go ahead and look at when this particular one is increasing. Okay, we'll go ahead and be consistent. Okay, I'm going to put the highlighter on for where it's increasing. So right here is where it's increasing. Okay, if we look at each of these, right, if I go from left to right, I'm starting left, right, I'm going right. Notice my pencil's going down, okay, as I go from left to right. But on this section, as I go from left to right, my pencil is going up. Okay, and so that's the kind of simple definition of increasing for that one. All right, and then notice it's decreasing over here. Okay, so the interval, right? Well, the interval is from here to here, right? And I want to look at my x values. Okay, intervals, when we talk about decreasing, increasing, or constant, are always going to be my domain. Okay, so it's from here to here. Okay, so all I got to do now is just find those x values. Right, I've got -1, 2, 3, 4, 5. Okay, so I'm at -5. It is starting to increase. Right, notice I put my parentheses just like what I was talking about over here. Okay, and then it continues to increase until -2. Okay, so that is the domain for when this function is increasing. All right, and that's it for that one. Okay, so for decreasing, all right, same thing. I'm going to go ahead and highlight my decreasing values, or my decreasing sections of the function. Okay, there it is. That is where the function is decreasing. Okay, so on this one, notice I've got the arrow, all right, but it's continuing left forever, right? So my interval is going to start at -infinity for this particular interval. Okay, and it's continuing to decrease until I hit -5. So I'm going to go ahead and stop it at -5. Got to make sure I have my open interval with the parentheses, okay? But that's not the only interval where it is decreasing, okay? The other interval where it's decreasing is this interval right here. It starts at -2, okay? And notice it is going to continue to decrease, okay? So I'm going to go ahead and put infinity there, and that is my decreasing interval. Okay, so again, we're always talking about the domains. We're always talking about what sections of x what is happening at those sections of x. Again, increasing, decreasing, or constant. Okay. Notice constant, we don't have any of those. Okay. It's never horizontal on this particular graph. Okay. It's either increasing or decreasing, and there's nothing in between. Okay. So if it were to ask for where the function is constant, well, you would say none or never or something like that. Okay, cool. Increasing, decreasing, and constant for this one. Okay, let's go ahead and label it. I'm just going to start left to right in this particular one. This section, okay, that's constant. All right, that is a horizontal line. That is a constant growth, right? My y is not changing. My y is staying constant, right? My y for this particular one is at 4 throughout this entire interval, okay? On the next one, okay, we've got decreasing, right? As when I'm at this point, as I go to the right, right, I'm starting from the left, okay, but as I go right, my pencil is going down, okay, still going down, all right, and I'm stopping here, okay. So that is going to be decreasing, okay, and the last one is increasing, right? As my pencil goes from left to right, my pencil will be going up, okay? So there we have it for increasing. Okay, and again, on this one, for whatever reason, I just chose to go from left to right. So let's go ahead and talk about my constant interval first. Notice I've got the arrow, okay? So all the way left, that's going to be negative infinity, okay? Open parentheses here because we always have open intervals or with parentheses for increasing, decreasing, and constant. All right, so negative infinity, it goes all the way up until negative 2, okay? Because that's this section right here, okay? Again, domains, all right? From what value of x to what value of x is it increasing, decreasing, or constant? Okay, and over here, right, there's another section, all right? That particular section is decreasing. I've got negative 2, and I'm going to positive 2. Okay, and then for increasing, I'm at positive 2 and going all the way up until that is a value of 9, right? So don't get confused. Notice that there's a closed hole here. Okay, if it was an arrow, right, it would be all the way up to infinity, but this one does actually stop this particular function. And so it goes all the way up until 9. And open interval with parentheses because that's what we always do for increasing, decreasing, and constant. Okay, so that is actually it for increasing, decreasing, constant. We're going to go ahead and flip to the back and talk about extrema. Okay, so with extrema, okay, so essentially what extrema are is it is points where the function changes between increasing to decreasing. Increasing, I'll go ahead and say increasing to decreasing, or vice versa. Okay, so when you're changing from increasing to decreasing, when the function is changing from increasing to decreasing, you are going to have, let's see, you're going to have a minimum. Okay, when you are changing from decreasing to increasing, you're going to have a maximum. Okay, and let's just look at a kind of a quick example. Let's look at this. Okay, notice on this original, from this first example, I am decreasing here. I'm decreasing and then I've got a minimum, okay, because I just now changed to increasing. Okay, so you're going to end up with a minimum when you go from decreasing to increasing. Okay, what if you flipped it around? Okay, what if the function looked like this? Okay, you are now increasing, now you're decreasing. Well, that's a maximum. Okay, if you were to flip it around. Okay, so that's what I'm kind of referring to there. It is not absolutely crucial that you know that now, but again, that is a very important concept moving forward into calculus as you, the goal is to get to there, right? Goals to get to calculus, and then so you'll kind of see where that becomes a big important concept then. Okay. All right. So relative maximum. Okay. So let's keep it simple. I'll go ahead and say the greatest value the function can attain in a given, I'll say over an interval, over an interval. All right. There can be multiple. Okay. A few points. Okay. One. No, I guess we'll go ahead and talk about the first one. So, as I kind of mentioned earlier, a maximum is where you're going from increasing to decreasing. All right. And then just something to note, there can be multiple for the relative. Okay, so the relative part of it, right? You've got, it's kind of a like random peak. Like if you think about like a range of mountains, okay, a range of mountains has multiple different peaks, right? Because there's multiple different mountains. Okay, but really the highest mountain would be kind of like that absolute maximum. Okay, but the relative is just, you know, the various different peaks within a mountain range. Okay, that's one way to think about it. And then kind of similarly, right, you could have like a I don't know, like a valley, right? Like relative valleys. Okay, so that's kind of what you would be referring to with minimums. Okay, so very similar, right? This time we're just talking about the smallest value the function can attain over an interval. Okay, and then to be consistent here, this time we'd be going from decreasing to increasing. Okay, and then there can also be multiple because it's a relative minimum. Okay, so the relative part is where that comes into play. Okay, so this is let's talk about the absolute maximum and absolute minimum. Okay, this is the greatest value. Go ahead and flip my pencil. Okay, with the absolute maximum and minimum, this time we're talking about the entire domain. Okay, so notice these are just various intervals, right? We've got a peak here, we've got a peak here, okay, for maximum, or we've got a minimum here, or a valley here for the minimum. Okay, but the absolute maximum is just that highest peak. Okay, the absolute minimum is that lowest valley. Okay, but we cannot talk about infinity, right? Like that's not. Infinity is not like an absolute maximum. Okay, it's not a peak, right? If you're just continuing up, like if you look at this right here, that's not a peak, right? There's no hill, okay? Or with the minimum right down here, there's no valley, okay? It's just continuing down, okay? So that's, you got to keep in mind with absolute maximums and absolute minimums, you may not have one, okay? You may not have an absolute minimum or maximum within the function. Okay, so there can be at most one. I'm not even going to write that. Okay, so the greatest value of the function attains over the entire domain. Okay, so this is the smallest value the function attains over, again, the entire domain. Okay. So those are the definitions. Okay, so let's go ahead and take a look at them, some examples. Okay, and then again, I'll kind of re-emphasize that whole idea of, you know, the infinite is not it cannot be an absolute maximum, and then the negative infinity is not the absolute minimum. Okay, let's go ahead and look at it. All right, we got a function. Okay, this is the particular function that we're looking at. Okay, and we are going to talk about what the relative maximums and minimums are. Okay, so one point I want to kind of just go ahead and start off with is, what is my range here? Okay, well, my range here is negative infinity to positive infinity. Okay, so because this is my range, we'll note a few different things here with the absolute minimum and the absolute maximum. Okay, so we'll kind of see how that comes into play. All right, but this right here, so the relative maximum estimate. Okay, the relative maximum or the relative wait, I'm confused. Oh, okay. Sorry. All right. So with the relative maximum, we're actually calculating it and estimating it here, but regardless. Okay, with the relative maximum, you're always going to be talking about y values, okay, or even with the minimums, right? So all this stuff, okay, for this, everything circled is going to be my y's, okay? So all of these, okay, are going to be y values. Okay, so what is the maximum? It's a y, okay, at a particular x value. Okay, so let's go ahead and just do all the estimates first, and we'll go ahead and begin. Okay, so the relative maximum estimate. Okay, so that is, again, where the function is going from increasing to decreasing. Okay, so let's go ahead and label it like we were. Okay, I've got blue here, increasing, and it stops. Okay, and then I've got blue here, and then everything in between is decreasing. Okay, so the relative maximum, I'm going to, we're going to just look and see if there's a hill, okay, and there is a hill, all right, there it is, okay, so we're kind of going to estimate what that y value is. Looks like it's about 3.1. Okay, at the x value of, I don't know, maybe negative 1.1. Okay, in order to calculate it, all right, so let's go ahead and do that. Okay, I can just show you real quick how we can calculate it. All right, we can put it into the graph, right, in my graphing calculator or Desmos or whatever you want to put it into. Then we've got minus 4x. Okay, and we'll click graph. There it is. There's that function. I'm trying to find that exact point. Okay, so one way to do it is to click second and then calculate. And then you've got your maximum button right there, actually. Okay, so it says left bound, so you're looking for left of the maximum. Okay, so I just need to get an x value that's left of the maximum, and then I kind of scroll over to get a x value that's right of the maximum, so that you see the arrows now it's in between, and then I'll kind of scroll over and estimate it. That's what it's at, or guess. And so I kind of get close, and there it is. Okay, so if we wanted to be exact with it, that's how you would do that. That's one way to do that. So I'll go ahead and say 3.08 at the x value of negative 1.15. Okay, so there it is. That's a maximum, a relative maximum. That's one example. Okay, so let's talk about absolute maximum. Okay, so now this is kind of where the range comes into play. All right, so notice my range, right? All my y values, okay, it starts way down at negative infinity, okay, and then goes all the way up to positive infinity. And so because it goes all the way up to positive infinity, you cannot have an absolute maximum, okay? It doesn't have a greatest peak, okay? Yes, there is a peak, okay, but it continues up forever. So it's just that particular peak, right, is just a relative, right? It's the greatest value relative to this little part right here, okay? But the function ends up continuing on forever, so you're actually going to have none here. I'll just go ahead and write none straight across. Okay, there is no absolute maximum here, all right? Relative minimum, this point right here, okay, looks like it's about at negative 3, x value of 1, okay? Same thing, we could calculate it. Okay, very similarly, you'll still go again to second calculate. This time you're going minimum. Okay, so left bound, really doesn't matter where you start it. and then right bound, and then estimate it. Okay, so there is my relative minimum. Okay, so about negative 3.08, negative 3.08. And then positive 1.15. So it kind of mirrors the other one. Okay, absolute minimum. The function goes down forever, so none. All right, and then the increasing and decreasing intervals. All right, so this is my first increasing. All right, so negative infinity stops at the exact value. Right, we found the exact value, so might as well. It's negative 1.15. Okay, but that's not the only increasing interval. We've also got this one right here. And so your value is, well, we found that point, right, to be 1.15. Okay, and then it goes up to infinity. All right, decreasing, right, it's just these two, right, it's that kind of middle section. So it's negative 1.15 all the way up to 1.15. And then there's no constant section in there. Okay, so I'm going to kind of zoom through this next one just to go real quick. Because I spent a lot of time on that one. All right, I'm just going to go ahead and label everything. Okay, so notice, we'll talk about my range real quick. Okay, it goes from negative infinity. Okay, and then it peaks. Just an estimate looks like it's about 3. Okay, just as a rough estimate. Okay, so my range, it continues from negative infinity to 3. So one thing I know is that I have two maximums here. I've got one here, and I've got one here. Okay, so it's not like this one over here where I didn't have a absolute maximum. On this one, I do have an absolute maximum. Okay, just to label them. Okay, this is my relative max. Okay, and this one is my absolute max. Okay, and then I also have, just to continue our labeling, that's going to be my relative minimum. Okay, all right, so the relative maximum, that's going to be just this one right here. Looks like it's about negative 1.5. Sorry, we want to talk about our y values here first. So it looks like it's about 2 at negative 1.5. To calculate it, we'll go ahead and put the function in real quick. Okay, we got negative x to the 4th minus x to the 3rd plus 3x squared and then plus 2x. Okay, there it is. Okay, calculate maximum. Go to the left of that peak, go to the right, go to the middle. Okay, so to be exact, there it is. You remember you put your y value, so it's 2.07 at negative 1.52. Okay, absolute max. Let's go over there. Second, calculate maximum. To the left, to the right. Guess it. You just got to get close. And then your absolute max, okay, is 3.04. And then the x value is 1.08. Okay, so there's the absolute max. Let's just go ahead and do the, while I'm here, we'll calculate the minimum. Okay, left bound, somewhere in there, right bound, somewhere there. Estimate, there it is. Okay, so I want to put my y value in. We'll go negative 0.31, and then my x value negative 0.31 as well. Okay, we'll go ahead and round it to that. All right, and then yeah, looks like it's somewhere in there. Maybe I would have guessed negative 0.25, negative 0.25, probably. So it looks like to me. Okay, and then the absolute minimum. Notice, because the function is going down forever, I have none here. Okay, so I don't need to write anything on that. Okay, and then once we've labeled all these, we can kind of use this information to get the exact intervals. Okay, I'm sure you kind of figured that out from here. But if you really wanted, right, you could totally label these points. Okay, just understand, right, with your intervals, you want these to be x values. Okay, they have to be x values here because we're talking again, like I said on the previous page, increasing, decreasing, constant. You're always talking about at what intervals of x are those increasing, decreasing, and constant. Okay, so let's go ahead and fill this in, but I will first label everything. Okay, we are increasing here. Whoa, increasing here, increasing here. That's it. Okay, the other spots I am decreasing. There's no constant. There it is. Okay, so the increasing. Okay, I'm starting at negative infinity. Right, and it's x values. Okay, so this thing does go to the left forever, even though it kind of just looks like it's going straight down. It does continue to the left forever. Okay, just ever so slightly, right? But it does. And then it goes all the way up into, well, we've got to think about what that point is. Okay, well, just so we know, that's my relative max. So I'll go look at what my relative max x value is. So there it is. That's all the way up into negative 1.52. I've got another one, so union, and then it restarts at the relative min x value. So I'll go to my relative min x value, so negative 0.31. And then I continue up until my absolute max x value. So my absolute max x value is 1.08. So if it helps, right? Maybe you could label these x values, but that's kind of your choice. But do anything that helps for you, right? Label these points if that's the case. That could be a helpful tool for you to have. Okay, decreasing. We kind of fill in the gaps from here. Okay, so I kind of know that what's in between here, right? That is this section. Okay, so I'm going to go ahead and do negative 1.52. Right? Remember, I did parentheses because increasing, decreasing, constant, always with parentheses, open intervals, negative 0.31, and then union again because I've got a second one, and then I know everything after that, 1.08, and it continues on to infinity. So with the kind of interval notation, just keep in mind one thing that gets confusing is like looking at those second values. They kind of look like coordinates, and we're so used to our brains thinking about the second value in parentheses with a comma is a y value. Okay, but note that these are x values. Okay, this is interval notation with x values. Okay, so x values. Okay, for my intervals. With increasing, decreasing, and constant. Okay, and that is it. All right, see you guys later. This is always the awkward part where I'm like trying to figure out how to turn off my video. Here it is. See ya.